Broadcast is now starting. All attendees are in listen-only mode.
It's just
I'm
Daniel.
going to keep my camera on just for the introductions, and then
Okay.
I'll
Everyone
turn
can
it
hear you.
back on when
All right, fantastic. Okay, we got a couple more people still logging in. We're going to give everyone a chance. I'm going to start the introductions while our last few people join us. Make sure I share the right screen. Yes. Okay, we're going to check our audience view. Very good. So we got a couple more people jumping in. Excellent. All right, well, let's get underway. We're a minute past the hour. As you know, my name is Ben Reese. I'll be your moderator today. I'm the Director of Marketing here at DCS. I've been here for about 10 years, and I want to welcome you all to our monthly webinar series. Today's topic is perceived quality, seeing the impact of variation. As you can see by the webcams, we have a guest presenter with us today. And the focus of today is to look at the value that perceived quality can bring to your organization when it comes to design and manufacturing and communication within your organization between the two groups. As part of our 2023 webinar series, the perceived quality is our March webinar. We do have the topic for our April webinar, how to combine FEA and mechanical in your prototypes, with a guest presenter from our partner Senate. So make sure you're signed up for the next event. As part of our series, being signed up for today's event will automatically sign you up for the next one, and we'll provide you with a recording afterwards. Throughout this year and next year, we are going to be hosting a number of guest presenters for our webinar series. If you'd like to be a guest presenter, you can enter in the survey afterwards, or you can let me know in the question pane or in the chat, or follow up with me after the event by replying to the follow-up email or reaching out to us at DCS on our website. We're going to showcase a number of professionals, so if you have a project that you would like to showcase or a type of analysis or something unique to your process that you'd like to show off, please let us know. We'd be happy to host you as part of our webinar series. Today's software will be 3DCS for CATIA on the 3D Experience platform. All of today's features when it comes to 3DCS are available on our other platforms. Some of the live rendering and visualization is unique to 3D Experience, but we do have a visualization export add-on module for 3DCS available to connect to other visualization platforms. Throughout today's event, please ask your questions in the questions pane. We will have a Q&A session at the end, but it's best to get them written down before you forget them. We also have a survey at the end when the webinar closes down. If you could take a minute to fill out the survey, it's only 5 questions and it's very helpful to us. Some of the questions include what topics you'd like to see on future webinars, as well as if you'd like to learn more about perceived quality and some follow-ups from the event itself. We do take your input seriously, so any topics you do put in are added to our list and most often are included in our following series. If you have any issues with your computer audio, please first change to phone call and then back to computer audio. This will reconnect you to the audio server and will correct most of your audio issues. A recording of today's session will be sent to you tomorrow via email to your inbox, along with some additional webinar links to other perceived quality topics. After today's event, feel free to share that email that you'll receive tomorrow with your team and to download the video recording for your network and to share with your colleagues. Many of our customers like to keep all of our recordings on their intranet in order to create an archive for future use. You can also request a meeting with an engineer from DCS if you'd like to see more or if you have specific questions you'd like elaborated on. Finally, if you have a moment to fill out the software evaluation, we are doing a full evaluation of 3DCS software in order to get feedback on future developments and current software performance. All right, that's enough housekeeping. As you've met before, Gary Bell is our Senior Dimensional Engineer and ASME GD&T Certified Trainer here at DCS. Has been with us for a number of years and is part of our sales support group. So Gary is most often pulled into these webinars to support us and many of our other events, whether he likes it or not, which, don't listen to him, he does like it more than he likes to admit. And we have our guest presenter here, Daniel Dresemann from Dassault Systemes, one of their dimensional engineers and perceived quality specialists. And Daniel has been working with us for a number of years and has become quite proficient with 3DCS software and is an expert on the 3D Experience platform. So if you want to sneak in a 3D Experience question, this would be the optimal time. All right, at this time, I'll be passing the presentation over to Gary.
To Gary?
To Gary, right?
No.
To Daniel.
Yes.
Yeah. Did you not listen to it? Yeah,
I did
Daniel.
listen. I did listen to most of it.
Yeah, let me see. Yes, that looks good. I hope you can see my screen now.
There we go. Perfect.
Wonderful. Thanks, Ben, for the introduction. And welcome to this webinar also from me. Yeah, it's about perceived quality, and let's get directly into this topic of today. So perceived quality is a very important factor for the product development process. To prove with that, I'd just like to give you two easy examples. So imagine you have a very valuable material you think for your product, and this has to be perceived by your customer in the way you have thought of. So basically, otherwise you will spend a lot of time and effort, and that may be for nothing. Another good example is if you think about your manufacturing quality, and that is really good. So you have a very good manufacturing quality in your factory. And this, and again, the same goes for your customers. They need to perceive it. Otherwise, you might lose a competitive advantage against your competitors. The question is now, how do you perceive that quality? So basically, how do you experience it? Basically, that's a kind of experience quality, and we as humans can only experience it by our human senses, right? So you can hear it, you can hear something, you can see something, smell, taste, feel it, basically. And today, I'd like to focus on the visual aspect, because it's also a very important factor for today's product development cycles. I'd like to give you some real-life examples in the first place to why those are important for visual perceived quality. So let's begin with the surface. The surface is a fundamental thing which has to be in a very good quality, otherwise it affects the whole downstream process, right? And a surface will always come with a material. A material is the appearance of, or will change the material, but you cannot apply to the whole product of the seat here. An example, you have just small patches. The next factor is something, as you can see here, or probably you cannot see, it's everything is black, is light. With light, we as humans can see basically everything, like the surface and the materials. It also has a huge effect on the material appearance. So we will see later how that looks like. And for sure, what we are talking about today is, or mostly about today, is gap and flush. And as you as a designer, engineer, or stylist have a design intent, and the gap is a part of the design intent because you have to manufacture it, right? So that is also a very important part, which is in real life quite easy to investigate. A very new topic, or let's say, which becomes more and more interesting in today's cars, are HMIs, so-called human-machine interfaces. So basically all our displays. They have two effects at the same time. They emit light, so they might change your appearance in the interior, and you can interact with HMIs, so with the display itself. So there are two factors why they affect the perceived quality of your product. Now comes the question, when do we want to make a perceived quality review? To answer that, we have to take a look at this generic product lifecycle template from design to the mass production. Historically, so it's a long time ago, but historically perceived quality validations could only be performed on a physical prototype, and until that, there were no chance to do these things. So in design, style release, or technical release, there were no chance to enhance or to do a perceived quality review. And you might have done that first on your prototype, on your physical prototype. And that could be that you're struggling to identify issues for the upcoming production. But when you introduce a digital tool to review and make perceived quality reviews, then we can really find issues earlier, and these could affect all the later steps positively, and we have a good impact and find issues earlier. That is quite good. So basically, that is also the answer on the question: when do we want to do a perceived quality review? We want to do it all along the process. And within the 3D Experience platform, we are offering a solution to do this. So we are offering our designers all the tools to make a stunning design. We are offering our engineers simulation tools to validate these designs or suggest new ideas. We are offering collaboration tools to really collaborate between the departments. And as I told you in the beginning, we want to experience this perceived quality, right? So we are offering experience on the 3D Experience platform. Let me show you quickly to wrap up these things on the 3D Experience platform. So we have tools for our creative designers to sketch and create surfaces out of that very easily in one tool. And after you have the first surfaces, we can provide them to the next teams, so the engineers or the surface refinement teams. They are doing then the right Class A surfaces, the real Class A surfaces which you can use later on in the process for production. Until that point, we are just having surfaces, and surfaces is just one part. I told you that that experience is a very important for that. And with the Visual Experience Designer, what we are offering, and the embedded application CATIA Live Rendering, we are enabling high-end visualization on your managed CAD data. So from here, we can go to here. So that is an experience. We have proper lights, proper materials, and a realistic environment around that, with a really good and powerful render technology which is based on our Stellar renderer. And here you can see a picture which is done on with the technology global illumination. So to get there, we have to make kind of a material research. And for that, we can use real-life materials, scan it with our technology partner X-Rite, and they can produce a really physically correct scan, which we can then apply to the surface, and we can validate, based on our Stellar physically correct renderer, these results virtually. So we have still the same connection here. For sure, what we can also do is, in the material research part, we can also visualize procedural materials like substances. That leads me to the part that we have now a few materials available. So now we need to make a decision. If you remember the example from before, or on our real life example, so we tried to put our reference materials here in real life on our product. We had just small patches, and now we can really put them on the whole product and really evaluate and make decisions easier. When we have done this part, we are gathering all the other materials, 3D surfaces, materials, environment variants, and put them together in a tool called Product Perception Experience, which enables us in a very intuitive way to try different trims and packages in the tool. So you can see we can collaborate together on that. We can collaborate together on the same data, talk about different trims, and save them for later reviews. I mentioned before also the part about the light factor is a very critical one. As you see here, with the mood light is changing, the material appearance is also changing from the product. So that's not only true for the interior light, it is also true for exterior light. So meaning all our ambiences coming out, and there's a sun, is it a night session, is it rainy or whatever. Everything affects our visual perceived quality here. And another very important factor is these displays you can see now here. These are also getting more and more parts or more and more space in our interior designs, right? So they can also affect with its light, which they are emitting, the visual appearance of our interior. But that is not only the only thing. I mentioned it before already. There's also the interaction. So you have an HMI designer who's prototyping in their dedicated tool, a HMI interface, or more or less the content of a display. And as you can see here, it is an HTML page. We can interact in there, and now we can also include that in our 3D, in our whole 3D scene. So meaning we have now the proper lights again, we have the materials around it, and you really can get the feeling of this. Does the interior, so no, does the whole content of your HMI fits into your product? So get the context. You can also, as you see here, you can also interact with it in 3D. So that gives us a quite complete check for our perceived quality review here. And as a last step, and now I want to really focus on Gap and Flush, because this talk is about Gap and Flush, is that was more or less an introduction, is that we are coming out to the part where also a collaboration is really mandatory. So that might be the first time, probably, where all the designers, engineers, manufacturing, planning people, and simulation departments might come together and meet in front of the car and say, okay, let's talk about it. So on the left, I have here an example where the designers had an intent for the surface and the material. As soon as it comes to manufacturing, there has to be a gap, because it could not build in one part, right? So there has to be a gap. Now the gap is part of the design intent. Another good example you can find here on the right side, where multiple materials come together, and they has to be separated by the gap. So again, the gap is part now of this material split and of the material intention here the designer had. In the following, I have some more examples where we can see how different materials can affect the visual appearance of a gap. So there might be a color where you can see the gap appears more noticeable, and there are also some colors where they appear less noticeable. To accelerate and enhance this whole process, we have a dedicated solution, a dedicated portfolio for that on the 3D Experience platform. On the left, I already introduced to you the Visual Experience Designer role, which enables you to visualize your managed CAD data. And on the right side, we have the Product Design Presenter, and I already introduced to you the application for that, which is the Product Perception Experience, where you can do, for example, decision-making or color and trim. And then in the middle, we have here the 3DCS variation analyst which is completely integrated in the 3D Experience platform. But before I hand over here to Gary, who will show you 3DCS in detail, I'd like to share with you the capabilities, how 3DCS can support perceived quality and visualization, no matter which process you are following at the moment in your organization. So imagine you have a shaping tool, and then you convert it and put it in your visualization tool and experience in VR. You could also do this with any platform 3DCS is running on. For example, you can export it to the visualization tool DeltaGen here. And that's, before I go to the next part, that has one downside. Any design modification which is requested, you need to go back to V5, for example, and start over this whole process. We are offering the integrated workflow. Everything is integrated. 3DCS is integrated. You can shape in VR. You can shape along the materials which are applied. You get immediate feedback about reflection changes if you have any, if you do any modifications on your 3D surface data. So everything is integrated, and that is a more or less a bidirectional process. And with that, I'm going to hand over to Gary, who will now show you 3DCS and all its capabilities.
All right. I think I'm supposed to share my screen. Can you guys see my screen?
It looks good, Gary.
Let me get some stuff out of my way here. So I'm going to talk to you. I got a couple slides. Thank you very much, Daniel. As you noticed, 3DCS is one of the analysis tools, and we analyze, component part variation to confirm that we can meet our specs that were defined earlier before the design started. And one of the tools that we have in our software is called Spec Study, this icon here. And there's a lot of words here. You don't have to worry about the words. I'm just going to describe it to you. So those of you that are familiar with our software, to do tolerance analysis, we have to define how the components index to each other. We have to tolerance our detail level parts. We have to write measurements. And then we run the analysis and we confirm whether or not our measurements, which is the specs we're trying to meet, are going to be in or out of specification. Well, with Spec Study, we don't have to assemble the parts. We don't have to tolerance the parts. It just gives us the ability to translate and rotate components to put them in a position to see any measurement at any value that we want. So I'm going to show you that. And that's done without any moves or tolerances to help you determine what specification is acceptable for the design. And as Daniel mentioned, we can use the spec studies, and he puts advanced visualization on because a gap that might have looked good from a dimensional standpoint might not look good when you put the advanced visualization on it. Once those spec studies are done, then you do have to do a full analysis. And in order to do a full analysis, you have to define how your components get assembled. And 3DCS is traditionally rigid body analysis. And when it's a rigid body analysis, you only get like what we refer to as a 3-2-1 locating system. So you can see if I had this fender, I can locate it to the body here, here, and maybe one point here for the Y direction. But when you do something like that, then you're going to get a lot of variation up front. And we know that fenders are flexible and they have more than just a 3-2-1 locating system. So then we enhance the software with Compliant Modeler, and Compliant Modeler allows you to over constrain the part. And so you see you will have, your original 3-2-1 locators, and then you can clamp it and, attach it at additional locators here. So if I jump over to 3D Experience, this is a minimized version of the model. And as I mentioned, you can see this model has moves in it and it has tolerances in it, but we're not going to talk about that. We're going to just talk about measurements. So here, you can see I'm measuring the Y variation, Z variation at the fender, and I'm measuring the traditional gap between the fender and the hood. And you can have any of the measurements that you write around the vehicle. And once those measurements are written, if I go into this measurement here, this is the spec limit. So this is what we're trying to validate from a full model, is that, hey, the design is 3 millimeters. We want to know if it varies within plus or minus 1, is that good enough? Will it look good enough? Is this what we want to accept as our spec limit, so that we can then finish the design and analyze it and see if we can meet that spec? So with that, you would then write spec studies. And if I go into a spec study here, this allows you to pick any of your measurements and you put them down in this list. This is a gap fender to hood minimum. So you can see the nominal is 3 millimeters, and we want to see what it looks like at the lower spec limit, which is going to be 2 millimeters. And you can either set it to your lower spec limit, your upper spec limit, nominal, or specify any value. And as I click through here, you can see, okay, so this is a fender gap max. So now it's set to the upper spec limit, and we want to push the gap to 4 millimeters. All of these over here are spec studies, and you can have an A gap and a V gap. And once you have all these spec studies, if I zoom in here, and I'll go to Quick Viewer, I can just come here and click through, and you can see the gap is opening, the gap is closing. This is a A gap. This is a V gap. So you can quickly pass through any of your settings here to get a visual. And then, there's more spec studies in here where, here you can see this is gap fender to hood deformation, where we opened up the gap in the middle and we closed the gap at the end. And so the idea is without the design being complete, you can put these panels into any position and visually look at it and say yes or no to establish the confirmation of what your actual measurement specs should be. Once those measurement specs are set, if I I can now separate this model, because this does have moves to define it, and there's that 3-2-1 move that was locating the fender. Of course, there's a move for the hood as well. Then I can go ahead and build this and deviate it. So now we can pick up the variation from the actual part tolerances and the build specifications. This is a rigid body model. So if I go ahead and build this, and we're gonna look at this Y variation up here on the fender. And if I run a quick analysis, and we look at that measurement, so you can see locating this fender based on points back here and 1 point in the middle. I'm projecting out, I have a high geofactor, and that fascia, or the fender to fascia fit, is quite bad. 8.12 millimeters. So we can have a single model set with multiple settings. Here's the compliant modeler. In the compliant modeler, you have to load some FEA data so we know how this part's going to deform according to its material properties and where it's all attached. And if I use our model variants, I can just quickly say, hey, I want to switch this over to a compliant model by saying apply this model variant. And now you can see it automatically turned all these moves on. And because this is a compliant model, we have to, let me separate this real quick. We have some components here that are also compliant. So we have a little more work to do because we have to join these parts together and then join those parts to this part so that the stiffness of all three of these become one. And that's what all these extra moves are, where we're just, holding the part so then we can weld it, this piece to this piece. And here we're welding these two pieces together. And now the stiffness of all three of those are combined. And then I can start clamping at all of the attachment points. We even simulated an attachment point up there. So with that, if I build this, and I zoom in here, if you just watch this corner here, when I hit deviate, it's a little slow, but this corner here is twisting in and out as I'm clamping the fender up here. So forces up here are being projected in here, and you can see how it's deforming the fender. If I go ahead and run this, this is going to take a little bit longer than the rigid body. A little bit longer. And now if I go back to that Y measurement, fender to fascia, you can see it's 0 because we clamped it back to the fascia. And so we can take a model and we can analyze it from a rigid body standpoint. We can analyze it from a compliant standpoint over constrained parts. And we can put the visualization on it and see how all of this is going to look in real life with the variation. So Daniel's going to show you, that if I go back into one of these spec studies, you can set your spec study. You can set your spec study to its nominal design gap, its upper and lower specifications, or if you run the analysis, then you set it to the specified amount. What did the analysis tell you? So that way you can look at your design and say, okay, this is what we're going to get from our assembly method and our component part tolerances. What does it look like? Is it acceptable? Is it not acceptable? And that's where, Daniel's going to go back and he's going to show you the variation with the advanced visualization. And with that, I will hand it back to Daniel.
Thanks, Gary. Thanks. Let me switch on my camera here again so that you can see me. Ben, do you want to do one of those polls, or should I go through that and show my screen?
Oh, that's right.
I'm going to put up the first poll. We have just a few polls today to get some feedback from all of you. Let me launch the first. If you have your screen maximized, you may have to shrink it down a little bit in order to interact with the poll. Sometimes it doesn't let you click if you have it completely maximized. Just want to get some feedback on if you're using spec studies currently.
So while you're doing that, because this webinar is focused mainly on advanced visualization, we've had a webinar specifically for spec studies. We're just throwing spec studies in here because this helps you quickly modify the location of your parts with advanced visualization so you can see what it looks like.
All right. So majority of guests don't look like they're the perceived quality and craftsmanship specialists, perhaps. Okay. Thank you very much for your feedback. We appreciate it. I'll give it back to Daniel.
Yes. So I hope you can see my screen again.
Looks like we are on the other screen. You might need to double check your sharing setting.
Okay. Yep. Let me do this. Let me do this. Yeah. That looks better.
Yes.
Can you
perfect.
see my?
Thank you.
Yeah. Okay. Wonderful. Yeah. So to wrap it up, thanks, Gary, for showing this all these nice capabilities. So basically, to wrap it up, as he said, he did all these design specifications as a designer from the design's perspective. The engineer is then analyzing its assembly process and trying to build it in the best way, basically. The cool thing now with visualization, and I will jump over to the E3 Experience platform now, is actually that you can do this within the visualization context on that model. So for example, you can switch colors here quite easily. You can look at the spec studies here, what we are doing right now. You have predefined cameras, like I mentioned before, and we are here in the CATIA product perception experience application. So just that you know in which application we are at the moment. But let's directly jump into the topic of spec studies and show some spec studies. So here we are. I have highlighted a few. There are all spec studies from Gary in here. I just I'm able to import that. But to get a little bit better overview, I'm just showing here some of my favorite spec studies to get you the best feedback here. You already see that is our real-time visualization, which is already quite good. But in terms of reflections and shadow calculation, we need to switch on our global illumination renderer, which is here Stellar. That is now active. And we still have the capability to move a little bit. You see that the performance is now a little bit has reduced, but still it is quite nice. That is the reason because what I'm using right now our little cluster that is running with our distributed Stellar commands. So Stellar is not only running locally, it is also running over the network. So we have multiple graphic cards which are supporting us to give us faster results within this calculation method. And the cool thing is you can linearly scale this this technology up. So we are using here right now 8 graphic cards at the same time, and you can use 16, 64, up to 4,000 graphic cards. And then you have really more or less a real-time global illumination review, which helps you to elevate this process better. So now you really get the idea that we have different reflections. We can zoom in here a little bit. Just let's zoom in a little bit on this one. To get a little bit better the reflections here from this from the lamps on the top of our environment here. A little bit to that side, nice. Okay, that's better. So that is now our nominal build situation, and let's enable, for example, first maximum. So that's really a subtle and light movement. So as we have seen it in Gary's presentation, these movements are very, very little. But as a designer, I don't want a lot of changes, right? So this should be checked quite easily. Let's have a look at for example, at this A gap here. So here's the maximum and here's a minimum value. It still looks okay. But if we take a look at this V gap, that looks not that okay anymore compared to what we have seen before. We have here a huge gap in the back at the A pillar, and here in the front, also at the place where the headlamp is located, we have a very tight connection. That might be that we should have a look at this spec study again. So I can here flag it actually as yeah, it's out. This specification study is, from a visual perspective standpoint, not what we want to offer to our customers. Yeah, let's imagine this one. On the other side, the other one, let's have a look at this A gap again. That's still okay from our perspective, and we still can compare it to our nominal default values. And I think that's quite nice. Let's have a look at two, here in this case, two flush measurements here at the front part. Let's have a look here and locate and navigate here down here, and let's have a look here at that one. Okay, we can really see here now. I hope you can see that through the stream, that we have a huge gap between the fender and the fascia here. And let's have a look at here. This is also strange behavior, but still better than the other one. But also the hood is moving. So if we take a look at here at the back of the A-pillar, we see also some differences. But let's change the environment very quickly here. We have here a kind of a light tunnel, which gives us a little bit more reflections and a little bit more information about where do these reflection changes has an impact. Yeah, and let's zoom. Let's navigate around that. And now look at from a different angle on these parts. Yeah, so now we can really see here nice reflections, these reflection lines and highlight lines. So this is how it should look like basically. Let's turn it around a little bit so that we can see it here, and let's have a look at again on these spec study here and really see the difference. What happens here in the front and basically also here in the back. Still, these movements are very, very subtle, yeah. And from the spec studies, we can mention them. Okay, these are still, in terms of reflections, good. So we can flag them as, yeah, let's say for an hour as in, yeah. But we keep them open and go back to the default value here. So first of all, we want to see how the rigid movements are working. Gary already showed that these are probably not very good, but let's have a look here also in terms of visualization. What effects does they have? So we really see here a lot of changes in the reflection. We see a lot of movements from the fender and on really something which is really not working in terms of the designer's perspective. And the cool thing is you can imagine that we really can sit together here as a designer and engineer and talk about the same understanding and visually see the impact of these changes. So I think we can agree that the rigid spec studies are not the one we are really interested in. Let's have a look at the compliant model. At the compliant results. So what I did is actually I exported the results which Gary provided me and imported it here directly from the same database. Yeah, we are working on the same database, on the same cut managed data, and imported it into my session here, into my product perception experience session. Okay, let's start by the default value, and probably let's change the color just for now, because we are able to do this right away. We don't need another physical prototype. Yeah, we can really look at these things from different colors. Let's take this metallic color, for example, in the first place, and have a look here with a predefined camera, which is cool because I already took a look at here a specific highlight I want to take your attention to, which is here at the place where the this little opening for the charger is. So let's have a look how these effects, how these compliant modelers has an effect. So this is actually here, probably we will move that a little bit up here. yeah, that you can see also the gap. It's a little bit better like this. But you see that we really have here a difference, and this is really the key point where we really see the difference in terms of reflections. We have reflection changes. As Gary mentioned, we have also here a flush measurement now. We need to take care of at the bottom of this fender. We see also that other materials looking through these looking through here, that means we really need another better solution for our assembly process. But that is something which looks good because we fixed here these two measurements between the fender and the fascia. But if we take a look here at these results, we see that we have to take a little bit more work into our solution to find the best solution for the assembly process for this fender. And that is actually, in my mind, the way how perceived quality, the visual perceived quality, can help you here to really, see the difference faster and easier, because you really have extreme reflection changes on your fender. What you can do as well, and this is something I just want to do very quickly, is, for example, you find a certain gap you want to show to your colleagues. Yeah. So, for example, this one, and you want to show them in all these 6 colors. We can use our so-called background render variants. Click on that and just click OK. So in the background now, the rendering will be processed while I will show you something else. So that will here pop up in a second. And then in the meantime, and after that has finished, I can show you these nice pictures from that view, and you can share these pictures. So you can see right away that the software is going through all the colors now, and rendering it basically. So coming back to these things here, let me just jump through this one. Oh, sorry, I jumped too far. Let me want to show you this, is that you not only can do this by yourself, so preparing everything, because I wanted to really show you the high-end quality here. And what you really can do is you can collaborate for sure on the same tool I've just used, and in this case, it's another example, another car, and you can really talk about the same gaps and flushes you have provided, and then you can show it you can show the spec studies to your colleagues in different colors and see the difference in your variations. Another very cool thing is you can also do a collaboration basically here by using our VR capabilities. So you can see me here in the bottom left corner, where I take a first look at a 1-to-1 scale of this model. I can here again change all the colors through, and wearing the headset gives me the opportunity to imagine that this whole car is, I really can see the difference of the spec studies here in this first place. I've put a trigger for the spec studies actually on the red sphere, and on the green sphere I put a trigger for the compliant modeler results. So that is really another benefit you can do in the 3D Experience platform. So just let me see if the results are already finished. So you can see now that the rendering is almost done. And in the meantime, if you want, we can do our next poll, Ben.
All right, thank you, Daniel. All right. As a reminder, if you have the screen maximized, it may not allow you to click, so you might have to just shrink it down a little bit. All right, thank you very much for your feedback. We'll just give 10 more seconds. All right, thank you. Share the results. Just interesting to see. Thank you very much for that. And then we have one more poll real quick. Just curious on how important high-end visualization and 3DCS spec study observation analysis is to your organization. All right, thank you very much. I'll share the results. Appreciate your feedback. This time, Dave, are you available? Are we moving on to Q&A, or do you have some more here?
No, I think we're moving on to Q&A. Ben, thank you.
All right,
Daniel,
excellent.
for that presentation. Very nice stuff.
Thank you.
Yeah, I have a couple questions for you. Daniel, you were showing that VR headset, right?
Yes.
That's is that like you have hand controls and a head control, or can you give us a little bit more detail what that hardware entails? I mean, a little bit more background about that.
Yeah, so you have a head. The headset itself has a display in it, and you can see the car then in 1:1 scale, and you have two handles in your hand, and then you can control actually that. For example, if you want to turn the car left and right, you can do this. You can do some interactions like switching the colors, switching the spec studies, and stuff like that. Yeah.
When you're looking at in the VR, is it like 100%? Like when we look at a screen, we zoom in and we zoom out on the CAD screen. What's the perspective? You know, when we're in the VR, is it like you're standing right next to the vehicle?
It is actually like you're standing next to the vehicle, yeah, right? So you have a kind of a bigger field of view. It's not that it's 2D in front of it. For sure, we're looking at the 3D model, but you're really surrounded by everything. You have the environment around you, and you're standing in that room actually. So like I showed in the video.
Very cool. Okay, can you give us just kind of an overview of some of the visualization terms? VR,
Yep.
HD, ray tracing, global illumination. And what do all these things mean? And when we're looking at CAD, typically, we're not looking at this shiny stuff. What do we typically call just CAD rendering? And just give us an overview of what the terms are.
Yeah, so VR is basically virtual reality. So VR can be used for anything what I've just showed you, or what is anything in 3D basically. We use VR actually for our headsets mainly. So basically, you're going really into the 3D with your headset. Global illumination, for example, is a render technology which really allows you to see the correct reflection calculation and to see the correct shadow calculation, basically. Ray tracing is pretty much the same with some differences, but for now, keep it in the same range, yeah. And what we are doing is we are applying realistic materials, realistic lighting setups, and a realistic environment, and that all provides you a experience which then leads to a lifelike or physically correct experience in the visualization context.
Right. These tools are very, very interesting. It looks very complicated. It looks very, not that you made it look complicated, but it looks like, boy, to be able to do that, you need to be an artist. Who applies these materials to the geometry? Do you need to have be an artist, or is this something that a designer does, an engineer? Who does this typically in an organization?
So typically, there are specialists for exactly this work. So there's actually a color and trim process. We're calling it the color and trim process, and there is actually people who are defining the materials, and then there are people who are really applying the materials to the model itself. So actually, in the end, there are specialists who are doing this job, and I'm, as an engineer, just want to reuse these materials and want to reuse the 3D object with the applied materials and do my review. I don't want to spend a lot of time, for sure, applying the materials by myself. So there are also experts for these domains.
Okay, so let's just say the materials are defined, like that's predefined. We know what materials we're going to use. You did some of the texture, some of the interior stuff. How long does it take to apply these materials? I mean, is it just click the part and it gets it on both sides, or I mean, do you have to pick each surface? How does it go?
It depends. It depends. You can define. So basically, we are defining a kind of a process where you really define, basically your company has a process where you define certain parts have certain colors, and then you're applying to these parts of this model a certain material. So for sure, you have to click these materials, but you to apply this material to a lot of shapes. And if you're an experienced user, this could be done in a day or something like that. So that's pretty easy to do.
Okay, and of course that's just part of it, right? So now, what about the environments and the lighting? Do these things need to be defined, or how does that all work out?
Very often in the organization, or what we are providing with the 3D experience, are predefined environments. So you just have a library for that, and then you can just use one of these libraries for these exteriors. For example, this light tunnel is one of our content libraries examples. Yeah, and you just drag and drop it from this library into your scene, and then you have it available, and you can directly use it. So there's no need of any preparation for environments.
Daniel, you're an expert in perceived quality, and we focus a lot about cars and transportation, that kind of stuff. I mean, what other industries besides automotive are looking at PQ and using this stuff?
So we are having also a lot of interest lately in the aerospace and defense industry. So companies like from the typical aerospace companies are questioning us in terms of perceived qualities in regards with materials. And then there's also the high-tech industry. So mainly these where you do washing machines, whatever, where perceived quality or gets really, really interesting in these kinds of stuff.
Very good. And what type of hardware is required? Is this a RAM intensive? This a CPU intensive video card? Can you run this and get this kind of rendering on a typical CAD workstation, or is it something different than that?
I think in a typical CAD workstation has already a very good graphic cards, video card in there. So that video graphic cards needs to be a 3D graphic card. For sure, RAM is good to have that, but it's not necessarily anything you need. But it's really on the graphic card. So if you want to have performance and this quality in a good amount of time, you should spend your money on the graphic cards, basically.
Okay, well, great. Well, Daniel, I want to thank you again for your partnership in doing this webinar today. And certainly, if people are interested in learning more about how to do this in 3D experience, that would be.
One quick question.
Go ahead, Gary. Yeah.
Hey, so when you said aircraft, are you guys mainly focused on the interior aircraft? Or
at the moment, the requests are going into the interior of the aircraft. Yes, cabin interior and compartments, maybe stuff like that.
That's what I thought. Okay.
Yeah, very good. Well, once again, thank you, Gary and Daniel, and Ben. We can wrap this up.
All right, thank you, Dave. Thank you again, Daniel, for joining us, and Gary for your time. And everybody else, appreciate you being here. You'll receive an email from us tomorrow morning with the webinar recording, both as a streaming option and a download option in the presentation. I'll include some additional links to learn more about perceived quality and spec studies in that email. If you have any questions, you can, of course, fill them out in the survey after today's event or by replying to the email tomorrow morning. We hope to see you next month for our Combined Compliant Modeler and Mechanical webinar, and hope that you enjoyed today's event. Thank you.
Thank you.